So this is my recording for Homework 8 for digital systems. Um, the task we were given was to design traffic light controllers described in the book. So the traffic light controller described for problem 14.3 I implemented as entity problem 14 underscore, prob 14 underscore 3. So it had to be designed around a table 14.4 in the book. So the state diagrams for that table look as such. So it had to have a reset, and then it had two sensors in the east-west direction. If a car was detected in the east or west, it would transition so that the car could go in the east-west direction. And then after that, it would transition straight back to the north-south direction being green. But in the original design, it didn't have where both north and south and east and west were red at the same time. It just went from yellow-red to red-green. So the problem was just to add in the rest state. So the design went from having only 4 states to having 5 states. Oh, excuse me. From only having 4 states to 6 states. Pardon. And the additional edge for when cars equals 0 stays in state 0, otherwise it transitions to the other states. And in Model Sim, I coded it like so. So I have a clock, a reset input, and the car east-west signal. And I have my outputs for the north light and the east-west light. Then I created a state type for all 6 states, and a current and a next state for FSM for the logic. Then if I have a reset, everything's back at state 0, else on every clock edge, current state's equal to next state. In my process block, as you can see, I labeled everything so you know when north is green, east is red, so on and so forth, and I encoded it where the first bit represents green, middle bit represents yellow, last bit represents red. So everything starts with the north-south lights being green and the east-west lights being red. Then it goes yellow, red after a car has been detected in the state 0. And then it goes red, 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 green, green for the east-west direction, then back to red, yellow for the east-west direction, then red, red for both north and south, and then it goes back to state 0 where north-south is green. And in my simulation, you'll see it works exactly as I said it would. So here, after I reset, you can see on this clock edge that since there's no car detected, that the output for the north-south light remains green. But when I reach here on this clock edge, it's detected a car, so it starts to transition to state 2. So north-south is now yellow, and east-west is still red. And here, east-west is red on the next clock edge, and then here on this clock edge, the east-west direction is finally green. And then it starts to transition back on the next clock edge. East-west is yellow, east-west is red, and then back to east, west being red, and north-south being green. Also, for my test bench, it was a very simple code. I created all the signals I needed in the architecture. Then I created a component for my test bench, and then I named it unit under test, and then hooked up all the signals. And then I send a reset signal, and then I send everything into a for loop. So so the clock changes every other bit since it's the least significant bit. Every other number. So since it's the least significant bit, like a normal clock would. And then the east-west signal goes off 4 times as slowly as a clock. So it takes 4 clock edges before a single jump is made. And the east-west sensor. And then it stays like that 4 times as long as well. Okay, so in problem 14.6, I use the same listing as 4.3, but in this problem we had another sensor for the north-south direction. So when a car in the east-west direction was detected, it would transition to the east-west being green, but it wouldn't transition back until another car was detected in the north-south direction, giving me two sensors. And you can see the names of the sensors make sense: car east-west, car north-south. Still the same number of states because it's a similar problem, but in this problem we only have 4 states shown in the diagram, and the edge for the east-west still causes it to go to state 1, but once in state 3 it won't transition to state 4 back to north-south being green-red until a car is detected in the north or south direction. So same as before, except for an if statement and right here that checks for the car in the north-south direction. Otherwise it stays in state 3 and the east-west direction continues to go. So I already ran the simulation. So as you can see here, I detected a car, but it wasn't on a clock edge, so no car was detected. In the north-south direction, it's ignored because we're currently on north-south. But on this clock edge right here, I detect the east-west car, so I start to transition. So my north-south light becomes yellow, and then becomes red, and then my east-west becomes green, and then it stays like that. And no cars detected, and then on this clock edge, still no car. But on this clock edge, right over here, a car is detected in the north-south direction, so it starts to transition back to state 0. So east-west become yellow, east-west red, north-south green. And that's the state diagram, and it's working properly. The test bench for this problem, pretty much exactly the same as the test bench for the other one, but with the inclusion of an additional signal for the car north-south. So I made it the count first bit. So count is the thing that's being counted, and this for loop that's being incremented and given values of I. So I can assign them bit positions, making clock the least significant, car north-south next, and then car east-west the next most significant bit, and then waits 10 seconds before it continues to count. Alright. Okay, so for problem 3 or 14.9, I was asked to use the same listing 14.4 in chapter 14 to design my traffic light controller. However, this time, in addition to only transitioning when a car is sensed, the east-west direction would remain green until all cars have passed. So as long as a car was detected, the east-west direction would not change. So it wouldn't go to state 4 until no cars were detected in the east-west direction. And then it would go back to state 0, and then it would start all over again if another car appeared in either the east or west direction. So the code is pretty similar to part 1. The only addition is an if statement right here in state 0. It checks if car 1's, in state 3, it checks if the car is east-west, and if a car is still detected, it will stay in the state, otherwise it will transition back to north-south being green. Test bench, in this case, pretty much an identical carbon copy to the test bench for problem 14.3. So I went ahead and generated the waveform. So here you can see that the north-south light's green and the east-west light is red. So when on this clock edge we detect that a car is in the east-west direction, so it starts to transition. and then once it's both are red, it holds, and it holds until the next clock edge where it senses no more cars, so it starts to transition back. And then here again, sensed, right here, then it holds it, starts transition, then it holds it, and it holds it. But the reset signal's here because it happens every time I restart the count, so that's the reason why this is like that. But it holds it, and that's pretty much it. So that pretty much concludes homework part 3. Homework part 3 and homework 8 entirely.